Hello everyone. Today we would like to discuss about the parabola in engineering graphics in eccentricity method. First of all, we discuss a problem. Draw the parabola whose focus is at a distance of 50 mm from the directrix. Draw tangent and a normal at any point on it. Okay. In this problem, the parabola curve we have to draw, and they are given in the focus distance is 50 mm from the directrix. In parabola problem, the eccentricity is always equal to 1. Okay, the eccentricity value less than 1 means it's a ellipse, and the eccentricity value equal to 1 means it's a parabola. The eccentricity value greater than 1 means hyperbola. Okay, in this problem they are given this is a parabola problem. This is a okay. So the focus distance is 50 mm. They are given. So we know the eccentricity. So parabola means eccentricity value equal to 1. From the vertex to focus distance equal to vertex to the directrix distance. So VF equal to VE. So the eccentricity is equal to 1. So then only the parabola means the eccentricity value is always equal to 1. Okay, in this problem, the given values we noted, and then we have to draw one vertical line. Okay, this is a vertical line. This line is noted as CD. This line is called the directrix line. From the directrix line, we mark one point E. Okay, then we have to draw one horizontal line. That horizontal line is always perpendicular to the directrix line. So that purpose, we are using protector. We keep the protector in a directrix line and mark the 90-degree. And then we draw the line through that point. Okay, this is called a major axis line. Okay, this line is called major axis line. Okay, next we have to find the focus distance. Okay, here the vertical line is CD, it's the directrix line. Here there's one of the horizontal line. The horizontal line is called the major axis. Now we have to find the focus distance. The focus is 50 mm from the directrix. From the directrix, we note the 50 mm. Okay, we mark the 50 mm and then we noted that point F. And then we noted that point F. Next, we have to find the vertex. In parabola, the vertex is always half of the focus distance. Here, the focus distance is 50. So, vertex is 25. From the directrix, we have to measure the 25 mm. That point is vertex. Okay, we use the scale. We measure 25 mm from the directrix and then we mark that point. Okay, we have to draw one vertical line through that point. Okay, through that point. Next, we noted that point V, vertex. Okay, that point is vertex. We noted that point V. Next, we use compass with the pencil. We measure the distance VF. Okay, we keep the compass in V and measure the distance F and then make an arc in above the vertical line. Okay, above the vertex vertical line. Next, we have to join that arced point and E. Okay, next we use the scale. We use the scale and join the arced point and E. We have to draw one line to these points. Okay, this is a border line. This is a border line for a parabolic curve. Okay, next we have to divided the 8 equal parts in 10 mm distance. From the vertex onwards, we have to divide the 8 equal parts with the distance of 10 mm. So we find that points. From the vertex, we have to find the 10 mm distance of 8 points. Next, we give the name that points 1, 2, 3, 4, 5, 6, 7, 8. Okay. and all the points have the 10 mm distance. Next, we have to draw the vertical line through all these points. That vertical point is till the border line. Okay, the border line onwards, we have to draw. For point 1, we draw the vertical line. In same way, we follow the vertical line for all the points. For third point, we draw the vertical line. Next, fourth point, we draw the vertical line. Next, fifth point, we draw the vertical line. Next, sixth point, we have draw the vertical line. Next, we draw the vertical line for the seventh point, and we draw the vertical line for the eighth point. Okay. Now we give the name for the above the border line. Here 1 means 1 dash. Here 2 means 2 dash. Here 3 means 3 dash. Here 4 means 4 dash. Okay. The vertical line touching the border line, that points will be noted. 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash. Okay. Next, we measure the 1 dash distance. Okay, we use the campus and fix the campus in 1 and measure the distance 1 dash and keep the campus in focus point, and we cut an arc in above in 1 dash line, and also cut an arc in below in 1 dash line. And this at the same time, the campus will be fixed in focus point. In the same way, we follow in all 8 points. We measure 2 dash distance and keep the campus in focus and make an arc above and below the 2 dash lines. Next, we measure the 3 dash distance. Now the campus is fixed in focus and make an arc above and below the 3 dash line. Next, we measure 4 dash distance and keep the campus in focus and make the arc in above and below the 4 dash line. Next, we measure the 5 dash distance, keep the campus in 5 and measure the distance f dash and fix the campus in focus and make the arc above and below the 5 dash line. In the same way, we follow 6, 7, 8 points. Now we measure the 6 dash distance. Okay, we keep the campus in focus and make the arc in above and below the 6 dash lines. Next, we measure the 7 dash distance. Seven dash distance. Now keep the campus in focus and make the arc in above and below the 7 dash line. Seven dash line. We measure the distance and keep the campus in focus. We make the arc in 7 dash line in above and below the 7 dash line. Next, we measure the 8 dash distance. Now we keep the campus in focus and make the arc in above and below the 8 dash line, 8 dash vertical line. Now finally we draw the curve, the smooth curve. The smooth curve will be started in vertex. Vertex onwards, we draw the smooth curve by using the arced points. Okay, that curve will be started in vertex. We join all the arc points. In the same way, follow in below the major axis. Okay, the smooth curve will be draw from the vertex onwards. We draw the smooth curve. Okay, next we draw we join all the arced points. Okay, we draw all the arced points. Okay. Finally, we got a smooth curve. This is a popularly known curve as a parabola. Okay, the parabola curve is always in a dark line. Okay, the parabola curve is always in dark line. For the dark line purpose, we are using HP pencils. Okay, the remaining lines are in thin lines. Where the thin lines purpose, we are using 2H pencils. Okay, this is a parabola curve. Next, we given the name for the arced points. Okay, here above the major axis arced points A1, A2, A3, A4, A5, A6, A7, A8, A9, okay, A8, okay. In below the major axis arced points are A1 dash, A2 dash, A3 dash, A4 dash, A5 dash, A6 dash, A7 dash, A8 dash. Okay, this is a parabola curve. In this problem, they are asked to draw the tangent and the normal line to the parabola curve. They didn't give any conditions to draw the tangent and the normal. They are asked to draw the tangent normal curve at any point on the parabola curve. So I choose one point here. I select one. I mark one point at any point on the parabolic curve here. Okay, I mark one point. That point is noted as point P. Now I would like to join P and F. So I join the P point and F point by using scale. Now I join the PF. Next I take the protector and I keep the protector in PF line and I fix F as a center of the protector. I keep the protector in PF line and focus F point as is a center point of the protector and I mark 90°. Now I join 90° marked point and focus point. Join and draw the line to these points and also extend this line to the directrix line. Okay, and also extend the line to the directrix line CD. That extension line touching the directrix line, that point is denoted as M. Now I join P and M. Now I join P, M points. Okay, this line is called tangent line. The tangent line is in a dark condition. Okay, now I would like to draw the normal line. The normal line is always perpendicular to the tangent line. Okay, now I take the protector and I keep the protector in PM line and fix P as a center of the protector and mark 90°. Now I join P and 90° marked point by using scale. Okay, by using scale, I join 90° marked point and a P point. Now I draw one line. This is called normal line. I noted the normal line in N. I noted the normal line as N. Okay. Finally, we have to mention the dimension. Here the focus distance F is 50 mm. So we have to mention its distance 50 mm. From the directrix onwards, the focus distance is 50 mm. So we have to mention that this is a extension line for dimensioning purpose. This line is extension line. Now I draw the dimension line. In dimension line, having both ends having arrowheads. Okay, the both ends, the arrowheads are there. The arrowheads must be drawn by using the templates. We are using the templates model for the arrowheads. In both ends, we draw the arrowheads in proper manner. Okay. Next, we have to mention the distance. We have to mention the dimensions, focus distance. The focus distance is 50 mm. We have to mention above the dimensioning line. The dimension distance is 50 mm. Okay. Okay. This is the final output of the parabolic problem. Next, we have to mention PM equal to tangent, PN equal to normal. All the dimension are in mm in the following method. All the dimensions are in mm. Here we have to mention. Okay, this is a final output of the problem. This is a final view. In this problem, this is a parabolic curve. Parabolic curve will be in dark line. The tangent line also in dark line. Normal line also in dark line. Remaining lines are in thin condition, thin manner. Okay, for dark line purpose, we are using HB pencil. For thin line purpose, we are using 2H pencils. Okay, finally, we have to mention PM equal to tangent. Here, PM. So, PM equal to tangent, PN equal to normal. All the dimensions are in mm. This is a parabola problem. Okay, next problem we will discuss in next class. Thank you.